Sorting is one of the most essential skills in programming, and bubble sort is a great way to start. In just a few minutes, I'll show you how to implement this classic sorting algorithm in Python. By the end of this video, you'll not only understand how bubble sort works, but also be able to write it yourself. Ready? Let's proceed. Bubble sort is a simple yet powerful algorithm that repeatedly steps through a list, compares adjacent elements, and swaps them if they are in the wrong order. Although there are more efficient sorting methods, bubble sort is perfect for understanding the basics of sorting and how algorithms manipulate data step by step. Let's get started by looking at the logic and then implementing it in Python. And if you're starting out with programming or want to dive deeper into essential algorithms like bubble sort, we have put together a comprehensive Python course that covers everything from beginner to advanced topics. It's designed to strengthen your fundamentals while also exploring advanced algorithms and data structures. As a bonus for our viewers, you can get 25% off using the code PythonHubSub. The link's in the description below if you're interested. Here's how bubble sort works. It iterates through the list multiple times. During each pass, it compares each pair of adjacent elements and swaps them if the first element is larger than the second. After each pass, the largest element bubbles up to the correct position at the end of the list. We repeat this process until the entire list is sorted. Essentially, the list becomes sorted one element at a time from the end. So let's jump into the code to see how bubble sort is in action. Alright, so the array here is 64, 34, 25, 12, 22, 11 and 90. This is the function that we'll be using. So first here we'll calculate n is the length of the array. Here we'll have to calculate what the length of the array is. That is, we can count 1, 2, 3, 4, 5, 6, 7. So the length of the array n, that is equal to 7. We use a for loop to go through each element of the array. The loop variable I ranges from 0 to n minus 1. Each time this loop runs, we place one element in its correct position from right to left. So the last I elements are already sorted. This means we reduce the number of the elements we need to check on each pass, making the bubble sort slightly more efficient. Inside the outer loop, we have another loop with the variable j, which goes from 0 to n minus I minus 1. This range reduces each time because the largest elements bubble up to the end of the array, meaning the sorted portion at the end is expanding. For example, on the first part where I is equal to 0, j will go from 0 to 5. On the second part where I is equal to 1, j will go from 0 to 4 and so on. So now here for each pair of adjacent elements, array j and array j plus 1, we check if array j is greater than array j plus 1. If it is, this means that the elements are in the wrong order and need to be swapped to sort them in ascending order. If the conditioning array j is greater than array j plus 1 is true, we swap the elements. This line of code uses a Python feature that allows us to swap two elements in a single line, moving array j plus 1 to array j and array j to array j plus 1. After this step, the larger elements moves one step to the right, bubbling towards the correct position. So following the example that we have taken here, let's walk through the passes of the bubble sort to see how the array becomes fully sorted. So this is our initial array, that is 64, 34, 12, 25, 12, 22, 11 and 90. For the first pass where I is equal to 0, we'll compare 64 and 34, and since 34 is the smallest or 64 is the largest and we need to swap it from smallest to the largest in the ascending order, we will be replacing 34 with 64. Swapping 34 with 64. The rest of the array looks like the same. So it goes Alright, so the rest of the array continues as it is. And now then we compare 64 with 25. Since we know 64 is a greater number than 25 and we need to arrange it in the order of ascending order, we will be swapping 64 with 25 and the order goes 34, 25, 64. Then it continues as 12, 22, 11 and 19. Now, next is that we compare 64 and 12. Again, we know that 64 is a greater number, and to arrange it in the ascending order, we will have the next number, that is 12, continued with 64 and rest of the array as it is. Now we'll compare 64 with 22. Again, 64 will be replaced or swapped with 22 and will be followed with 64, 11 and 90. Now 64 will be compared with 11. Here again, since we know 11 is a smaller number and we have to arrange it in the ascending order, we'll arrange it as 34, 25, 12, 22, 11, 22, 11, 64 and 90. Now comparing 64 and 90. Here we have since we know that 64 is the smallest number in comparison to 90, it will be in this order as follows. So this is the final array after pass 1, that is 34, 25, 12, 22, 11, 64 and 90. After this we can start with the second pass where I is equal to 1. So we remember the pass that we had after the first pass, that is 25, 34, 12, 22, 11, 64 and 90. So first we will be comparing 34 with 25 and we again know that we have to swap 25 with 34. So our first number here will be 25, followed by 34, 12, 22, 11, 64 and 90. Then we'll have to compare 34 with 12 where we'll swap both the numbers, wherein our next number will be 25, 12, 34, 22, 11, 64 and 90. Now we compare the next number, that is 34 to 22, and again we will swap 34 with 22 to place it here, continue with 34, 11, 64 and 90. Comparing 34 to 11, again we will place 11, continuing with 24 to 25, 12, 22, 11, 34, 64 and 90. So again we will compare 34 with 64 and we know 34 is smaller than 64, so our array will be right. So the array after pass 2 will be 25, 12, 22, 11, 34, 60 and 90. The third pass where I is equals to 2 is also done the same way. You just have to keep comparing it to the number adjacent to it, find out which number is bigger, and swap. So at this point, the process will continue in the same way, with each subsequent pass sorting one more element in its correct place. Each place will reduce the number of comparisons needed until the entire array is sorted. So similarly, if we keep following these steps, the bubble sort algorithm will eventually give us a full sorted array. So if we run the previous code and we find a final output, and after completing all the passes, we'll end up with the final array, that is 11, 12, 22, 25, 34, 64 and 90. And that's how a bubble sort works. It's a simple but effective sorting algorithm for small lists or introductory learning. We went through multiple passes to understand how elements bubble up to the correct position one step at a time. And that's bubble sort. In just a few minutes, you've learned how to implement and optimize bubble sort in Python. Remember, while bubble sort isn't the most efficient sorting method, it's a great way to build your understanding of sorting algorithms and how elements can be arranged in order. If you enjoyed this quick tutorial, make sure to like and subscribe to Python Hub for more Python tutorials and coding tips. See you in the next video.